We have already done that.
Yeah.
So what is it?
Standing wave is formed by destructive interference between two coherent sources.
No, no, you're talking about superposition. I'm not talking about superposition. I'm talking about what is meant by stationary waves.
Stationary waves, they don't transfer energy,
That's
and they
fine.
have nodes and antinodes.
You're actually telling the difference between standing waves and stationary waves and what you call it, the other progressive wave. A stationary wave is actually formed by the superposition of two waves having same frequency and amplitude but opposite in direction. Like
Mm.
when you do that, actually it's a sort of a loop which actually formed like that. So these waves are
Yeah.
because they are having the same string, right? So wave produced in
Yeah.
the same string, we can say same frequency there, and amplitude is also same. So when these two kind of waves are actually interacting each other, or you can say when superposing each other, they form a wave called stationary wave. We call this wave stationary wave or a standing wave because it has a limit. It actually will not progress as the other waves are inside the medium, but it continuously move into into single medium. It goes to one end, it reflect back, then come back. So it actually forms a sort of a loop there. All right. So this is what we
Yeah.
call as superposition. If somebody will ask you what is what is stationary wave, you will say that it is formed by the superposition of two waves having same amplitude, frequency, and they are opposite
In
in.
opposite directions. Yeah.
This is called what is this is called your stationary waves. Now, what is the
Yeah.
comparison of the progressive wave? You already told one. One wave, there
Yeah.
is antinodes and nodes. The other wave, we have it, definitely. One wave is stored
Mhm.
energy, the other wave do not store the energy. Next wave, very important wave. Amplitude in progressive wave are same for all the waves. While on the other side,
Yeah.
the amplitude will be different for each and every point. Next part is the velocity will be different for different particles in the wave. I'm talking about stationary. While on the other side, the velocity or the speed as the wave moves through a medium, that is what the wave speed is. On the other side, each particle of the wave oscillate at a different wave speed, right? One of the most
Yeah.
interesting part is that in phase points are coming right after the one lambda. I think so. I have told this concept that one
Yeah.
lambda means that the point if you draw a straight line there, then you can easily draw the straight line. While on the other side, the nodes which you actually have it, they within the nodes, the points you will find out are in phase, but beyond them, like for example, let's take it as example here. If you got a way here, let's have another one. If this is your node and this is your node, this point is not in phase with that point because it is beyond the nodes. But if it is within the nodes, like I'm talking about these two nodes, then you will find the points which are in phase. So points on
Yeah.
either side of the nodes are out of the phase. Points between nodes are in phase. On the other side, like for example, if you're talking about a wave here, then this wave and this point are basically in phase. And this
Yeah.
point will come right after one complete wave. Okay, that's what we have already talked about. What my point is actually, let's quickly see what actually my point is. Let's suppose this is a wave. If you remember what we have said that this is 1L, this is 2L. So lambda is equal to 2L. That is the first point we have it because
Yeah.
1L is going on the other side and one is coming back. Now, second one is if there are two loops here, same thing here, they reflect back. So in that case, the lambda will be lambda by 2, technically speaking. So I can say that lambda will be L because this is your L.
Mhm.
If there are three, then it will be, if I say so, one wave and the half. So basically, I can say that lambda will be equal to by 2 by 3. 2 by 3 L, not 2
Mister,
by.
for the first one, is it L over 2 or 2L?
You mean this one, the first one?
This one where it says lambda 2 is equal to 2L.
You mean overtone you're talking about?
The first harmonic.
I will tell you. Just give me a minute. I'm just revising it so that things gonna be easy. I will tell you what overtone is, what everything is, because this is our topic, and that's what the revision is. What my point is at the moment, let me draw it again. The first one is this wave, single wave, right?
Yeah,
Now this wave is basically equal to, if I write it, lambda is equal to 2L. This is the first harmonic, and we also give it a name called fundamental.
fundamental.
Now let's increase the loops, right? Now there are two loops. If I ask you what is the wavelength, then wavelength will be this one. Or you can say half lambda by 2. Or in other words, if it's lambda by 2, then lambda is equal to L, right? It's just L.
Yeah,
Now what about, it's called as second harmonic. And the second harmonic is also called as first overtone. Remember that first harmonic is not the overtone, second harmonic is the first overtone. Now the next one. Now you got this. Now as the lambda reducing, here the lambda will be how much? It's divided by 2, it's divided by 2, and here it will be. I can write this one as 2L by 2. Can I write it like this?
yeah,
Can I write it like this? Now the next one will
yeah,
be 2L by 3. Why 2L by 3? If you check this out, they are divided into 3 phase, or you can say in 3. So 2L divided by 3. That 2L will be divided into 3 number of loops. So all the
yeah.
time your 2L will be divided into number of loops. So what about, this is your second, I mean first overtone, then this is second overtone. Or you can say third harmonic.
Right. Yeah.
What if I call you the nth harmonic? The formula will for the lambda will be 2L upon
N.
n. Now this is the generalized formula to find out the lambda of that particular system, which is called stationary or standard, right?
Yeah.
Now, if you ask me what is the frequency, then I know that frequency is equal to V is equal to F lambda. If V is equal to F lambda, then lambda is equal, I mean, then frequency will be equal to V upon lambda. Am I right?
Yeah.
So F is equal to V divided by 2L upon N. Or in other words, it will be NV upon 2L. This is your frequency of that particular loop, what do you call that? Standing wave. If I ask you, find me the frequency of loop number 3, or you can say 3 loop standing wave, you can do that. At this point, I have a small numerical sort of a thing, or you can say practical. Yes, it is the one. I want you to just go through that quickly, and we will just see what exactly is what. Let me just rub that. Now, actually, they made a sort of a pulley stretch with a string and everything, and they are finding the frequency at which that particular string is vibrating. Okay. So now
Yes.
the system, they are actually doing that. Not, where is it? Sorry. This is the frequency, the general frequency when there is one loop. Can you see that?
Yeah.
Now this is for n is equal to 1. For n equal to 2, it will be half of the lambda, or in other words, 2L upon 1. Same way, when it increases, in generalized formula, lambda n will be equal to 2 upon n upon into L, where n is equal to 1, 2, 3, 4, 5, 6. Now, another very important thing for Fn, we have is equal to Nv upon 2L. At this point, I want to say another thing which is very, very important. There is another formula. Fn equal to Nf1. Please write that formula as well. It means that if you know the fundamental frequency, you can find any loop frequency in that, because fundamental frequency is very important. If you know that, you will simply multiply that with 2, 3, 4, 5, depending on the question, and you will find that particular number of loop frequency. You tell me if lambda actually reducing, frequency will be
Increasing?
increasing. So now basically, how many formulas do you have? One is lambda n is equal to 2L upon n.
Yeah.
One is Fn is equal to Nf1. One is F1 is equal to Nv upon 2L. This is all we have it in stationery, at least for your course. There are further formulas, but we have only this. I didn't see anything else. If you find anything, let me know. Because as far as my knowledge is concerned, you do not have resonance. And do you have resonance in your course? Do you ever go through this resonance thing?
Yeah, we do go through resonance.
Resonance, you have it, right?
Yeah.
Okay, so it means resonance, we have to do that. Okay, one more thing in resonance, if you have the resonance, do you have other formulas for that as well? I will check it out and I will let you know them. For the time
I
being,
think we have formulas. We have the concept there.
you have the concept.
Yeah.
We will talk about that
We
because in
we have
resonance,
damping also.
because you know what resonance is actually. At this point of time, what we are taking, we are considering both the points are fixed point. In resonance, your one point is fixed, but the other point is actually free. So in that case, your formula for the lambda frequency will be a bit different. So that's a bit different thing, but we will go through that. Don't worry. For the timing, it's just for the one in which both the ends are fixed like this. Wave go there
Yeah.
and come back. So these are the three formulas. I want you to write them. Standing wave when both the points are actually fixed, technically speaking.
So we also have photoelectric effect and IR and
Yeah, we have
like at
it.
levels.
Yeah, but for this, after this, we are actually we are passing going through the young modulus, right? After young modulus, we will go to photoelectric effect and then IR. You're saying IR is what? Can you just elaborate? I mean,
Infrared.
what
This
is
is
it?
using infrared
Okay. This one we will go. Don't worry.
to
Infrared,
identify elements. Yeah.
radioactive, and all this, right? Yeah, definitely.
Yeah.
Okay, now let's move further. And there is a numerical which is there. But young modulus, young double slit experiment is very important, on which we will be in
Yeah.
coming to. Okay, now there is a question here. Now check this out. B part is actually, A part is possible mode. The B part, they say impossible mode. What do you mean by impossible mode? And why they say impossible mode?
Because you can't have an antinode at the end.
Yes, so it's impossible mode. Okay. Now, point is begins with the velocity of wave on a string. Tension is equal to the weight of Okay, by using this one, we can use weight as mg and the tension of the weight which actually given to you, and mu is mm, mass per unit volume, I think, mass per unit weight or something.
Yeah.
So this is your mass.
Philip.
Yeah. So basically, this is your velocity. So this is one, I think we have done this formula. This formula will be actually provided to you, or you should know that if tension is given, you simply take a root of tension divided by mu. Mu is mass. Yeah, mass. So technically speaking, if you see the diagram above, where is it? In the start. So basically, mu is a dm upon dx, mass per unit distance. But I'm not interested in this. What I am interested in is, let's suppose you already know that. Can you find me the frequency F1 for this? All the details are given. Length is also given to you.
For F1.
F1. Take V as a value 57.15. So how will you
Okay.
find out F1? Simply use the formula above and you will actually came up with the frequency F1.
Okay, I'll try it.
Also find me F2 and F3.
So what is length again?
Lambda is 2L upon N. Formula is there already. You don't have to find lambda, separately. You can simply use the Fn equation, that is Nv upon 12, where V is given,
Yeah.
N is 1, and length is given as 2.
Okay. It's F1 14.29.
And what about 13.29? Okay. All right. We'll see.
14.29.
14.1. And what about F2 and F3? Can you please find out?
Mhm. It's 28.57 for F2.
Okay.
For F3, it's 48.86 or 2.86.
Now check it out. Is it fulfilling Fn is equal to NF1 formula?
Yeah.
So that's what I really wanted to show you. Now, exactly in standing wave, we got these three formulas. We have left up with the resonance only, okay? And once you
Yeah.
understand this, again, I will come back to Young modulus, right?
Yeah.
That was on my topic. Now, let's jump to Young modulus once again, which actually we were doing last time. And we left up with the Young modulus thing. Now, Young modulus once again. Let me just come back to Young. All right. First important thing, last time we came up with few things. I just wanted to show you the actual picture. Actual picture is like that. First thing first, what exactly we are doing in this? That's what our point is. Our point is actually, it was a long discussion between Huygens and Newtons for a very long period of time. Newton was saying that actually light was a particle. That's what his point of view is. And Huygens was saying light was a wave. You know, for a very long period of time, this discussion ends up in the winning of Newton, because at that time Newton was very famous and there was no concrete solution, that no concrete answer that actually light is actually performing, or light is a wave actually. After a very long period of time, maybe about some years, 50 or 60 years, that scientist Young came up with an experiment called Young double slit experiment. And by doing this experiment, Young proves that light has a wave nature. So basically, this experiment is being performed to show that light is a wave nature, because diffraction is the phenomena only done by the waves. It will never done by the particles. Particles can do reflection, not even refraction. But initially, Newton was the one who said light is a particle because light performs reflection. Now, once we are there, we already understood what superposition was. Superposition is simply when you have two waves and they are superposing each other. I mean, superpositioning each other. For interference, what is the condition, Manu?
Constant say it has to be from a coherent source, and the conditions for coherent is the same frequency and
Yes,
constant phase.
absolutely. So there are three things in that. One, the light should have a same coherence or will be coherent light. It is only and only possible if the frequency is same and phase difference is constant. Otherwise, it's not possible. So amplitude are also same in some way or another, but sometime it may not be. But important thing is frequency should be the same or coming from the same source. And the second one is it. I mean frequency is same, and the second thing is phase difference are constant. Whatever the phase difference will be, they are constant. Now my point is, what if they are not coherent source? What will happen? If two different light sources are there, then what it affects?
There won't be interference.
Actually, you will never find the clear picture because at the output side, you may not find the bright or the dark fringes properly because we need a proper result so that we will be able to find out or we will be able to conclude something. What if there are multiple colors at output side? What if you do not have proper color fringes at the output side? So how can you actually judge that? If the light is the same or a same laser light with the same, what you call it, same wavelength, then and only then you will be able to find out. So same frequency waves, and secondly, phase difference should be constant. You never use the sunlight because maybe sunlight will break up into its constituent colors, and if it does happen, then you may not get the proper result at the output. Okay, understood?
Yes, sir.
Okay, now let's start with the experiment. What we are actually doing this. First of all, if you check this out, there are two slits. That's the reason this experiment called as double slit. One is here and one is here. It means light has two ways to actually reach to the output side. When light passes through these two slits, it makes different color patterns at the output side. Some are called bright patterns and some are dark patterns. If you see that this is white pattern, then there is a gap. Then there is a white pattern, then there is a gap. Then there is a white pattern, there is a gap. Then there is a white pattern, there is a gap. Actually, this white pattern is called bright fringe. And this dark pattern within that is called as dark fringe. So when actually what happened, when this light source, which is one light source, and the light is passed through that one light source, it strikes there, and then the different patterns are actually achieved. Now, what the scientists are saying at that time, the bright fringe means you will have constructive, you will have a constructive interference. And where there is a dark fringe or there is a dark space, they call it destructive interference. My point is, what do you think of it? Phase difference be the same all the time, or will that be changing all the time? In
I'd say
all,
the same.
no, it will be different. The reason is light when reaches to this and this light reaches to that, there will be different phase difference or path difference, you can say.
Yeah.
But because they are constructive interference, we call it there must be path difference. The best path will be when they are at the center, and what we believe it at this point, the path difference is zero. And when the path difference is zero, there is always a bright fringe at the center. So remember that when it was seen, it is always bright fringe at the center. All the bright fringe or dark fringe from the top side will be n value as positive, and all the fringes which is at the bottom will be n is equal to negative. Now here, when I say n is equal to 1, it means order number 1, order 1, bright fringe of order 1, dark fringe of order 1, bright fringe of order 2, dark fringe of order 2. So basically, the results you achieve are constructive interference as well as destructive interference. Some waves, some points are constructively joined together or superimposed to each other, some destructively. Now, let me show you. This is your double slit. Waves are going from here. At this point, they are just strike them together. Then at this point, they strike them together. Then at this point, they strike together. Where they show minimum, it means destructive interference. Where they show maximum, it's constructive interference. And the fringes are like that, which are shown at this place. Do you understand that?
Yes, sir.
Okay. Now, once you find them, check this out. Now, this is a very good picture to show the constructive interference and the destructive interference. Check this out, that what happened here. Here, trough will fall on crust and crust will fall on trough. So at this point, when there is an interference, this is a destructive interference, or in other word, dark color is obtained. While here, your your crust will fall on crust and trough will fall on trough. So what you will get is as a bright interference, or you can say bright color is achieved. Okay.
Yes, sir.
Now this diagram, when you find out that you got dark is destructive interference, bright is constructive interference. Now we need to find out that path difference, which is very, very important. This is the formula for the path difference. Now, what do we mean by path difference? That's what we need to find out. Let me just rub that. Wait a second. Now, what is the path difference? Path difference we have to find out. Now, check this out. I'll increase it so that you can see a proper. Now, if you see this, and this young double slit, what is this D? Small d.
Slit separation.
It's a slit separation. So I can say it's a slit separation. Okay. And
Yeah.
the important thing is if I say that point and that point, how much is the phase difference? Then phase difference will be if I draw a line from here to this point. Because from here to here and from this point to this point, they will have the same distance. There is no phase difference. Only phase difference is this small part. So actually we have to find the value of this small part. Understand?
Yeah.
Now, if you see this diagram here, this is a sort of a triangle. Like this. This is your theta. Now, if you see that this is 90 degree, technically speaking, I'm talking about this. Between that and that, it makes a 90 degree. So basically, it will be like this. This is your angle theta. This is whatever it is. This is D. Now, what is your phase difference? This point. So how to find out? Sorry, wait. Just a second. Now, if you check this out, what I wanted to show you is Because when you draw a line, this is the straight line you draw it. So basically this angle is 90 degree. So if I draw that separately, it will be like this. This one is 90 degree. Now, if this angle is that 90 degrees, not 90, I mean theta, and that side is D, then what is that distance? It will be opposite upon hypotenuse. So sine theta is equal to, let's take it as, this will be whatever it is, let's take it as delta L or whatever. So this will be, no.
Delta L over D.
If I take delta L upon D, so delta L will be equal to D sine theta. So we reach to a conclusion that our phase difference, or you can say path difference, is equal to D sine theta. If the angle will be given to you, and if the D, the separation will be given to you, you can very easily find out the path difference. This is one of the formula to find out path difference. One of the formulas. Any problem in this?
No, sir.
Now at this point, for example, if you want to find out the wavelength as well at this point, then remember that that path difference value will be 0 when there is a constructive interference. Am I right?
Yeah.
Now I'm writing something, check it out. If path difference is 0, it's a constructive interference. If a path difference is lambda, it will be a constructive interference. If a path difference is n lambda, it will be a constructive interference. So for constructive interference, the value should be n lambda equal to d sine theta. This is for the constructive interference. So in young double slit experiment, if they are asking you the wavelength of, for example, what I meant to say that n is equal to 2 or n is equal to 3 times the thing, then you can very easily find out the lambda value if d is given to you and theta will be given to you, at what angle the light will be actually given to you. And n will be the order number. What if it's a destructive interference?
It will be lambda by 2.
Lambda by 2, or then 3 lambda by 2,
Yeah.
5 lambda by 2. So I can say that n plus 1 by 2 lambda equals to d sine theta. This is for the destructive interference. So we got a formula for constructive interference or destructive interference. N is the number, order number actually. If you place n equal to 1 there, it will be the order number 1, then order number 2, order number 3. What if you place n is equal to 0? What will happen?
N is equal to 0.
Practically, what is
Then
n?
there will be no lambda.
It means you are at the center, where both the light rays are very easily meeting at one point. The intensity of the wave at the center will be maximum.
Yeah.
Afterwards, definitely the intensity goes down, but constructive interference and destructive interference, it depends.
Yeah.
But central point will always be, like, for example, if I say this is the center of the screen, then this point is always, there is a constructive interference. If you go above, it will be positive n values. If you go down, it will be negative values. N value should be negative doesn't mean that it is something to do with n. It's just you are at the below side. Understood? I want you to
Yeah.
write these formulas now. We will solve some of the numerical based on that. Before we go for the some other formulas, we will find out some questions related to that. I think Monday onwards, uh, your two other friends are also joining you as well.
Yeah.
Okay. Then I want you to just help them as well. I will be uploading these files, and because you are not the senior one, I want to say, but you are being there with me for a bit period. They are only there with me
Yeah.
for last 6, 7 classes. So I want you to just combine together. You're living nearby or far away? What?
We live in Dubai.
No, no, I know, but you're living different parts of Dubai, or you live very nearby to each other.
Yeah, different parts.
Okay, but you study in one school, right?
Yeah.
Okay. Okay. All right. Now let's see the some of the questions. There are some calculation. See here. I just wanted to show you one. Did you see that the intensity at the center is the maximum,
Yeah.
and intensity at the first side may be smaller or whatever, but definitely if there is a constructive interference, there is a constructive interference. These points, these are the kind of patterns you always obtaining. So that is what the things are. Now, there are some questions related to these. Let's see how do you solve it. Let's solve it. The question is, suppose you pass light from a HE. Can you read the question or shall I enlarge it a bit?
I can read. I can read it. Yeah.
Let me just enhance it. Now I think you better can. Okay. The question is, wait. Suppose you pass light from HENE laser through two slit separation by 0.0100 millimeter, and finding the third fringe line on the screen is formed at an angle 10.95 relative to the incident beam. What is the wavelength? How will you find out? Which formula will you apply there?
And it's
You got
d
two.
sine theta.
D sine theta is there, but D sine theta will be equal to what? It's a bright fringe.
Is 0. Wait,
No,
it'll be like whole number, like
n
n
lambda,
lambda.
because they say third fringe, third bright fringe.
Yeah.
So D sine theta is equal to n lambda. Put the values in, get me the value for lambda. You need to change everything into meters. Remember that,
Okay.
right? Try that. If you have finished this, that's fine. If you don't, then maybe your friends will join you in for photoelectric effect. So let's see. Because I think in the next lecture we will be doing, if we finished with this, we will be doing
Yeah.
resonance because there are formulas related to that as well. And I think we better finish them as well. There are 2, 3 small formulas.
Yeah. So is it 6.3 times 10 to the power of -7?
Let's see. And if I ask to find me the frequency, can you do that? Yeah, this is the one.
Yeah.
So you can change them in nano as well. How do you change it? Just change it into 10 raised to power -9, and it will be in nano.
Okay.
What about Armstrong? If I say Armstrong,
Armstrong.
A Armstrong, like that. Might be you heard it first time. A this. This is called Armstrong. Armstrong is equal to 10 raised to power -12.
Okay.
So you
It's
can
like
say,
femto.
yeah, Armstrong. Normally we use that, but I think so nano will be fine. Leave that.
Yeah.
But I'm just saying if there is Armstrong sometimes, D means 10 raised to power -12. Because
Yeah.
most of the time the laser light got a very small wavelengths. So normally we consider these things, these small units, rather than writing 10 raised to power -12, 10 raised to power minus this, we use Armstrong. Doesn't look bad actually. It's easy to remember rather than you're
Yeah.
remembering the 10 raised to power -12 or something. It's difficult to remember. Okay, so answer is right. Okay.
Yeah.
Now, if you see 2, 3 digit, this is the wavelength of light emitted by the common HENE laser. Not by coincidence, this red color is similar to the emitting by neon light. More important, however, its interference patterns can use to measure wavelength. Young did this for visible wavelength. This analytical technique is still widely used to measure electromagnetic spectra. We don't use it anymore, but yes, some places we do use it. Okay, now I want you to try this part. Question is the equation D is equal to sin theta describe the constructive interference for a fixed value of D and lambda. N is can be easily found out as well. If all the details are given, you can find out N as well. Now let's see that. You can find out the number of fringe as well. Now, I want you to try first two questions. At what angle is the first order maximum for 450 NM wavelength blue light falling on the double slit separated by 0.500 millimeters?
So, sir, the equation for this
What?
is 15 fringes.
Yeah, first order means N is equal to maximum. Maximum means it's a bright fringe.
Okay.
Sometimes they use the word called a maximum minimum for bright and what do you call it? Constructive and destructive interferences. So when they say first order maximum, it means that they are talking about bright fringe.
Yeah.
So which formula will be used in this?
What angle? So it'll be
D sine theta.
the
Same thing. D
yeah.
sine theta is equal to n lambda or m lambda, whatever. Some books write it m lambda, some book writes it n lambda. It depends. M or n means the same order.
Was 64.16.
Okay, let's try that. Wavelength is given as 450 into 10 raised to power minus 9. That is lambda. And first order means n is equal to 1. Maximum means bright fringe you're talking about. So d sine theta is equal to n
And
lambda.
lambda.
So theta is equal to sine theta is equal to n lambda upon d. N is 1, lambda is 450 into 10 raised to power minus 9 over d. D is how much? 0.
0.0.
What is the value coming up?
So without the sign -1.
Yeah, what is it? After taking sine inverse.
It's 64.
So basically, it means that angle at which this is actually launched or whatever it is, it's 60 degrees. Can you try the second one?
Then I'm getting 0.99.
The answer is how much?
0.99.
But they say angle, right?
Yeah.
Very small angle. Why this angle is so small? I mean, it should be some degrees. 0. Check it out
Yeah.
again. It shouldn't be this much small angle. Let's check it out. Let's check it out. Calculate the third order. Okay, this one is lambda. So calculate the angle of the third maximum. Okay, so this is angle is sine theta is equal to 3 multiplied by lambda is 450 into 10 raised to power minus 9 and divided by d. D is 0.100. Can you find me this value, please?
It's 580, the wavelength.
Oh, sorry. I'm sorry. It's 580. Now, what is the value?
You're still 0.99.
0.99. And now take a sine inverse of it.
I have taken the sign inverse when I calculated it.
Again. So what was the value?
I got 81.9.
Yeah, 81.9. That's why I confused it. It wasn't that 0 degree or something.
Yeah.
Okay. So I think we stop here and I want you to go through that. And tomorrow we will continue from here. There is one more small topic, actually, a part of this young modulus, French spacing, and we will be doing
Yeah.
that. And once we finish with that, then inshallah from Monday, we will be starting photoelectric effect. And then slowly but surely, we are going to the radioactivity and all this. Okay.
Yeah.
Okay, then. See you. Allah Hafiz. Take care.
Yes.